Hello, so this is the first installment or first lesson that we covered on Monday, February the 24th. This is just a brief recap of what we did in class. We mainly worked on expanding stuff, and we talked about the distributive property. We talked about foiling or crab claw method, where it's basically distributive property with binomials like over here. And we also talked about a couple of formulas that might come in handy when expanding things. So we'll go over those, not in all the detail, but in some of it. So again, here, distributive property states that you have to expand by multiplying whatever is outside the bracket into every term in the bracket. So we know that the terms are things that are separated by an addition or subtraction sign and have different variables. So unlike terms cannot be combined into a single term, so they're still different terms. So here the 2 multiplies into the x and 3, the negative 3 multiplies into the 2 and the 4, and the negative 1 over here multiplies into the x and into the positive 7. So here we have a 2x plus 6, negative 6x minus 12 from this guy, and then a negative x minus 7. And then we just combine like terms. So I'm sure you're familiar with that. Combining like terms gives us the final answer there. So here we're going to learn the crab claw method, which is basically multiplying a binomial by a binomial when you have 2 brackets here. So here what we are going to do is take this x and multiply it into the x and the 3, and then the 7 you multiply into the x and the positive 3. So here x times x is not 2x, it is x squared, because something times itself is it squared. So that's important to remember. Then we have a plus 3x, because we do that. Then we have a plus 7x. And then we have a plus 21. Usually, if you do this in the same order that I've done it, these terms, the middle 2 terms, will add together and give you plus 10x. But again, this is just combining like terms. You see, we have an x squared term, we have an 2x terms, and a constant term. Again, just to point out that the coefficient for a term without a coefficient is 1. 1 is the invisible coefficient here, and the x squared points to the variable. A couple of us were confused in class, but just to point out that the letter is the variable and the number next to it, or to the left of it I should say, is the coefficient, and that includes the sign that's in front of it. So if I have like a 3x minus 5y, usually the coefficient of x is a positive 3, coefficient of y is negative 5, so that usually includes the sign. We want to consider subtraction as negative signs, so maybe they'll read this as 3x plus negative 5y, just so that we're not losing track of the negative or getting confused with subtraction or things like that. Yeah. So continuing our FOIL, this is the same case, just with a couple more numbers and a negative sign. Again, 2y times 5y, you multiply the numbers, 10. Y times y is y squared. We'll remember that there's a key difference here. There's going to be always a key difference pointed out between adding, subtracting, which are basically the same thing, and then multiplying, dividing, which are also kind of the same thing. We know that, like, if you do 2 divided by 3, that's just 2 times 1 over 3, and things like that. So they're grouped together because they're essentially, you can rewrite them in different ways. And so this is again just expanding stuff. Multiplication, you just multiply the numbers, multiply the variables. Adding and subtracting we can only do for like terms, so it's terms with the same variable, and then it's just like adding apples. So like you have 5 apples or 5x plus 6 apples, and that just gives you 11 apples. So you add the coefficients. You have to remember integer addition, of course, but you keep the same variable. The variable does not change. So continuing here, we have a plus 4y minus 35y minus 14. Like terms, please group them. Here we have an interesting formula. First we'll do it the long way. So here again, it's the same idea. You just FOIL, expand this. you have an x squared, you have a plus 6xy, you have a minus 6yx, and then you have a minus 36y squared. And then here are like terms. Notice that the order in which I write variables doesn't matter, because we know that multiplication, like 2 times 3 is the same as 3 times 2. So therefore x times y is the same as y times x. I should start writing my x's more. xt. But yeah. So these cancel out because you have a plus 6 and then a minus 6, so that becomes 0. So you're left with x squared minus 36y squared. And we'll talk about the formula a bit towards the end. So here we have 2x plus 3 the whole squared. Please do not write this is 4x squared plus 9. I've even seen some cases where 2x squared plus 9 is written, which is not even taking the square properly. So all these are taboo. We do not write these things. We expand, we do the FOIL expansion by writing it out like this. So we do 2x times 2x, which is 4x squared. Then we do a 2x times 3, which is a plus 6x. Here's another plus 6x. And then we have a plus 9. These two add to give you plus 12x. And again, there's a formula here that we will cover at the end, since we're almost at the end of our sheet. Here, this is just a combination of the two. First, we do I just wrote that over again. That's kind of pointless. Whenever you do expanding, I'd advise you to throw on brackets. So keep the brackets until you're sure they can be removed. I've added an extra pair of brackets here just to be safe. And even here. So interestingly, let's look at this one. 3 times x minus 4 times x minus 4. We have to be very careful here not to distribute the 3 into here, because that is not how it works. First thing, we have to do the exponent before we do the multiplication. This is like Bedmas. Following the rules of Bedmas. So we do the squared first. So we do x minus 4 times x minus 4. Now that it's written out like this is just 3 multiplied by this, multiplied by this, right? So it doesn't matter whether we do this first, so we can write 3x minus 12 times x minus 4, which means I've put the 3 inside here, or we can do x minus 4 times x minus 4 first, and then multiply a 3 into that. So that's what I'm going to do. I'm going to do 3, and then I'm going to do x squared minus 8x plus 16. And then minus 4x squared plus 4x plus 1. Again, we're going to talk about how the formula I used here. But here, again, we just multiply the 3 into all the terms. This is just distributive property. 3x squared minus 24x plus 48 minus 4x squared minus 4x minus 1. It's important to distribute this negative as well to all 3 of the terms, because again, it's a negative of this entire thing, right? So the negative goes through all the terms, and then you just collect like terms, and then you simplify these things. Hopefully we're good with that. So we're going down. Whoops, wrong way. Again, this is more of just an expanding thing. We're not using, it's like a crab claw. We just multiply everything in this by x and everything in this by -2. Again, hopefully it's not too hard. You can look at the answer key if you really need to get the answer, but hopefully we're in class and you saw this was like a 2x cubed, because we did x times x squared plus x squared minus 7x minus 4x squared, etc., etc. Combine like terms, and we're good. The formulas I said I'd go over, which are important to know, are a squared minus b squared. This is called the difference of squares formula, and that gives you an a plus b times a minus b. It's important to note, so for here we'll be expanding, so we'll just focus on going this way. And usually whenever you see like anything where you have of the form like 3x plus 2y and then 3x minus 2y, for example, you know that this is a plus b times the same a minus the same b, right? So this is a squared minus b squared, and that's taking the entire thing squared. So 3x squared minus 2y squared is what the expansion will give you. So we can directly write 9x squared minus 4y squared instead of doing, actually the crab claw or FOIL. But that's up to you. Technically, if you do the crab claw here, it will just take you like maybe a couple more seconds, but it's not the end of the world if you do that. The next formula that we did, and the last one we're going to talk about, is the sum or difference of square. No, I shouldn't say that. There is no formula for a squared plus b squared. That is just a squared plus b squared, just to note. But a plus b the whole squared, where you do a plus b and then you take the square of that, is interestingly not equal to a squared plus b squared. Again, like we mentioned up over here, it's not equal to just this squared plus this squared. You have to do the FOIL, but in doing so, the FOIL, you will realize that this is a squared plus 2ab plus b squared. So that's the formula. An example, we can even look at the one that we did over here, 2x plus 3 the whole squared. This 2x here was a, 3 here was b. So we did a squared, which is 2x squared, plus 2 times 2x times 3, plus b squared, which was 3 squared, which gave us 4x squared plus 12x plus 9, which is the same as this answer here. Again, this is just a slight shortcut over traditional foiling, but I highly recommend that we get used to these formulas, especially with the practice, just so that this will help a lot when it comes time to factor stuff. So yes. Okay, so we'll meet again when we do the homework, and of course in class. I'll see everybody later.